good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are going to talk about how to find the distance between 2 points. So, let's get to it, shall we? All right, we'll come back to ABBA towards the end and the great tune Waterloo. So, if I have 2 points on the coordinate plane, let's say I have point A at 1, 3, starting from the origin over 1 up 3, and then the point 4, 1, getting there in the same manner, and I want to find the distance between them, I could draw a right triangle. I could go down from A and then over to B, and I got myself a right triangle, and then we can use our good friend Pythagoras with the right triangle. And if you recall that the Pythagorean theorem states that a squared plus b squared is equal to c squared, and we just have to remember that c is the hypotenuse of the right triangle opposite the right angle, and a and b are the legs of the right triangle. So in this case, d squared hopefully, obviously, will be equal to 2 squared plus 3 squared, or 3 squared plus 2 squared. You clean that up and you get the square root of 13. Okay? If we take that another step and we do it generally using variables to represent the 2 points, and we do some algebra, we get the wonderful distance formula, because any 2 points on a plane, I can form a right triangle with it and use the Pythagorean theorem to find the distance between the 2 points, because the distance between the 2 points is the same as the length of the hypotenuse. And I know you've seen the distance formula. Maybe you didn't understand why it works, but here it is, and we are going to use it. I also like how they say that the distance between 2 points is the x step. In other words, the distance between the x coordinates and the difference between the y coordinates. And if you think about it, this makes perfect sense here. x2 minus x1, the distance between here to here, I can just subtract the x2 minus the x1 and I get this distance. And the y value, I can get the vertical distance or vertical length, y2 minus y1, gives me this distance here, which is the same as the height of the triangle. So let's just do a quick example with that. We have the distance between the 2 points, and so we say the distance is equal to the square root of x2 minus x1, and it doesn't matter which pair we make x2 and which pair we make x1, so I'm going to go against the grain. I'm going to call this my x2 and this my y2. Actually, I wanted to make those ones just to prove my point. x1, y1, and x2, y2 here. It doesn't matter either way. It's just they both have to be, if this is x1, this must be y1, and so on. So x2 minus x1 right here would be negative 2 minus 3, the quantity squared, plus 1 minus 4, the quantity squared. So this is the square root. Negative 2 minus 3 is negative 5, the quantity squared, plus 1 minus 4 is negative 3, the quantity squared. Let's clean that up. So that's the square root. Negative 5 squared is 25. Negative 9 squared is 9, or I'm sorry, negative 3 squared is 9. 25 plus 9 is 34. So they're the square root of 34 units long. That's perfectly fine to leave it like that. If I want an estimate, or if an estimate is needed for a decimal, we can crank it in our calculator. But for now, we are good. All right, so let's take a look at some more examples. Consider the points A, B, and C, and use the distance formula to determine if the triangle is equilateral, all sides equal, isosceles, 2 sides equal, or scaling, no sides equal. So what we're going to have to do is find the distance between each of these points, between A and B, between B and C, and between A and C. No sides equal. So I thought maybe if we plotted these points, it might be a little easier just to see. Negative 2, 0 here. Let's see, 1, 2, 1 right here. And 1, negative 3. 1, 2, 3. Looks to me like it could be equilateral. I'm not sure. But I'll connect the points. And at any rate, we would have to prove it. So this might be worth it if you got some graph paper, just to give yourself an idea. So this was A, this was B, and this is C. So the distance from A to B, and just the AB together means the distance between point A and point B. And let me go back and get our distance formula doohickey. I'm going to copy that and put it right back over here so we have it. Okay, so AB is going to be equal to the square root of x2 minus x1. So here's A and here's B. And this time I'll use this as my x2. So 2 minus negative 2, the x-coordinate, squared, plus 1 minus 0 squared. And this is equal to the square root of 4 squared. Because 2 minus a negative 2 becomes 2 plus 2. So that's 4 squared. 1 minus 0 is 1. So that's 1 squared. So that's the square root of 16 plus 1, which is root 17. Oh, this should be the square root of 17. I'm an idiot. Okay. So now BC we do in the same manner. And this will be equal to the square root of negative 3 minus 1 squared plus, I did the y's first, sorry. It doesn't matter if you do the x's first or the y's first. 1 minus 2 squared, the difference in the x coordinates. So that's equal to the square root of negative 3 minus 1 is negative 4. Make sure you use the parentheses with the negative there. Plus 1 minus 2 is negative 1 squared. This is turning out peachy. Negative 4 squared is 16. Negative 1 squared is 1. Root 17. So at the very least, we know we have an isosceles triangle. And now let's find AC. That's the coolest distance, AC. All right, so now we'll do our x's, AC. So 1 minus a negative 2, the quantity squared, plus, so we did 1 minus negative 2. Now we're going to do negative 3 minus 0, the quantity squared. That is equal to the square root of 1 minus negative 2 is a 1 plus 2. So that's 3 squared plus negative 3 minus 0 is negative 3 squared. That equals the square root of 9 plus 9. 3 squared is 9, negative 3 squared is 9, which is square root of 18. So while it looks like it could have been scaling, it is indeed isosceles, because AB right here is equal to BC, both of length square root 17. So our triangle is isosceles. So that would be the answer. And of course, you would have to show the work to prove it. Use the distance formula to show that ABC is right angled. If A is 1, 2, B is 2, 5, and C is 4, 1. And again, I think it's a good idea to graph it. There's A is 1, 2, B is 1, 2, 1, 2, 3, 4, 5. And C is 4, 1, 1, 2, 3, 4, 1. So this is C, this was A, this was B. And we can make some nice lines there. Boom, boom, boom. And this way you can tell where the right angle is. Clearly it's going to be here. Okay, so let's find the distance between A and B. It equals the square root of the difference of my x terms, 2 minus 1 squared, plus the difference in my y terms, 5 minus 2 squared. That is equal to the square root of 1 squared plus 3 squared. equals the square root of 1 plus 9 equals the square root of 10. BC, that's the hypotenuse, is going to be equal to the square root of 4 minus 2 squared plus 1 minus 5 squared, which is equal to the square root of 2 squared plus negative 4 squared, which is equal to the square root of 4 plus 16, which is equal to the square root of 20. And then the last distance we need is AC, the other leg. Again, another cool side. So 4 minus 1, the quantity squared, plus 1 minus 2, the quantity squared. That is going to equal the square root of 3 squared plus negative 1 squared equals the square root of 9 plus 1 equals square root 10. Now it says to show that triangle ABC is right angled. So we have root 10 here, we have root 10 here, and we have root 20 here. So we have to show that A squared plus B squared equals C squared. This is the show part. So A and B are my two legs. So root 10 squared plus root 10 squared has to equal root 20 squared. And the square root of anything is the number under the radical, if you recall. So the square root of 10 squared is 10. Square root of 10 squared is 10. Square root of 20 squared is 20. So I have 20 equals 20. Booyah. We are done with that. So I think that's going to do it. And I am out.